So, good afternoon, everyone. Uh, Welcome to the webinar. Thank you for joining. I am Duti, currently working as a data engineer in OpenLM, and our today's topic is big data and big insights. Let's learn how big data can be handled from BI platform. So, today our table of contents are big data, BI to rescue, big data analytics, future of big data, OpenLM and big data, and lastly we will move to Q&A. Let's start with our first topic, what big data actually is. So first we need to understand the explosion of data in recent years. There are several reasons. Let's learn one by one. Like first reason I will explain is data in digital transformation. With the rise of digital technologies, business, governments and individuals have digitalized their operation, leading to the generation of vast amount of digital data. Everything from email, media interaction, online purchases to sensor data from IoT devices contribute to this data deluge. Next is internet growth. The widespread adoption of internet has significantly contributed to the exponential growth of data. With billions of people accessing the internet and generating content every day, platforms like social media, streaming devices, and e-commerce websites produce enormous volumes of data. Next, it's IoT, Internet of Things. The it connected devices such as smartphones, smart home devices, and sensors is various industries that led to generation of massive amount of data. These devices collect data on everything from user behavior to environmental conditions, creating vast streams of data. Big data technologies. The development of big data technologies such as Hadoop, Spark, NoSQL databases has enabled organizations to efficiently store, process, and analyze large volume of data. These technologies allow businesses to derive variable, vulnerable insights of their data and make data-driven decisions. Machine learning and AI. The advancement of machine learning and artificial intelligence techniques has further fueled the growth of data. The algorithm required large amount of data to train models effectively, leading to increased demand of data across various industries. Data regulation and privacy concerns. The growing awareness of data privacy and security has led to implementation of regulations such as GDPR and CCPA, which requires organizations to responsibly manage and protect personal data. Next, we will move to key component of big data, which are volume, variety, value, velocity, and veracity. Let's learn it with example. Volume refers to sheer amount of data being generated, stored, and processed. Variety is big data comes from various forms, including structured data like databases, semi-structured data like in JSON format or XML, and unstructured data, which are text, image, videos. Dealing with diverse data types and formats is significant challenge in big data analytics. Velocity refers to the spread of which data is generated, processed, and analyzed. With the advent real-time data streams from source like IoT devices and social media, big data systems need to handle data in motion and make time-sensitive decisions. Next is value. Extracting value from big data involves transforming raw data into actionable insights that drive business decisions and add value to the organization. Veracity refers to the reliability and trustworthiness of data. Big data often includes noisy, incompetent, and inconsistent data, posing challenges in ensuring data quality and accuracy. Addressing veracity involves data cleaning, validation, and quality assurance process. Next is example of big data sources. These are very known topic for us. Like social media, Facebook, Twitter, Instagram, LinkedIn generates vast amount of data in the form of user interaction, posts, likes, shares, comments, and more. TV and video games, streaming devices like OTT platform, gaming platforms like stream produce massive amount of data through user interaction, viewing habits, gameplays, and preferences. Next is transaction details of a customer. Banks and financial institutions collect transaction data from customers' purchase, withdrawal, transfer, and other financial activities. Banking data accumulate data on customer accounts, loans, credit card transaction, ATM uses, and fraud detection. E-commerce site, online retailers like Amazon, eBay, and others, volumes of data through product searches, purchases, customer reviews, and recommendations, and search history as well. Internet of Things connected, such as smartphone appliances, wearable devices, industrial sensors, and vehicle, generate real-time stream data. Satellite data on weather params, led natural disasters, urban developments, and environmental changes, providing variable insights of weather forecasting, agriculture, urban planning, and disaster management. Web browsing, search engines like Google, Yahoo collects data from user search preferences, browsing history, and clicks website visits to personalize search results as target advertisement. Big data challenges. This is the main thing we face up from big data. So managing big data poses several challenges for organizations. Poor data quality is a significant issue as traditional methods may struggle with the sheer volume and diversity of data, leading to the accuracy, completeness, and consistency issues. Scaling traditional systems efficiently to handle large data volume can also be problematic, resulting the performance bottlenecks and increased processing times. Furthermore, the wide variety of technologies involved in big data, along with the need of integration and analysis across platforms, adds complexity and management challenges. Additionally, the expenses associated with the scaling traditional infrastructure to meet big data requirement can be considered. Ensuring the accuracy and reliability of big data, especially with unstructured sources, presents verification challenges. Integrating data from various sources can be error-prone, impacting data inconsistency and interpolability. So here comes our BI business intelligence to rescue. Let's learn what is the role of the BI. First is data integration. BI platforms excel at integrating data from disparate sources, whether it's databases, cloud applications, spreadsheets, or IoT devices. Next is data analysis and reporting. BI enables users to analyze data and generate insightful reports quickly and efficiently. We can see in this GIF that data is coming from various sources, and after after using BI, we can generate data visualization in a structured way in Excel sheet, and also we can generate the reporting. Next is performance monitoring. BI platforms often include performance monitoring features that allow organizations to track key performance indicators such as KPIs and metrics in real time. Next is ad hoc querying. BI tools empowers users to ask ad hoc questions for their data on the fly without needing to rely on IT or data analysts. Predictive analysis. We will move this, we will discuss this predictive analysis in details in our next slide. For now, BI is increasingly incorporating predictive analysis capabilities, allowing organization to forecast future trends and outcome based on historical data. Scaling and flexibility. BI platforms are designed to scale with the growing data needs of organizations, whether it's increasing data volume, expanding user bases, and adding new data sources. So these are the role of the BIs. Next, we will move to our third topic, which is big data analytics. So first we need to learn what are the four pillars of analytics. First is descriptive analytics. Involves summarizing historical data to understand past events and trends. Purpose is what actually happened in the past. Example is like visualizing website traffic over time, creating dashboard to monitor inventory levels. Next is diagnostic analytics, which diverse deeper to data to identify the root cause of past outcomes and anomalies. Purpose is why did this happen? Like investigating the reasons behind the sudden increase in customer churn or analyzing factors contributing to the disease in a product sales. Next is predictive analysis. Uh, Predictive analytics forecasts future outcomes and trends based on historical data and statistical algorithm. Purpose is what is likely going to happen, like predicting customer demands for a product. Last is prescriptive analysis. Prescriptive analytics goes beyond predicting future outcomes by recommending actions to optimize decisions and outcomes. Purpose is what should we do about it? Example, recommending personalized marketing strategies for individual customers, optimizing supply chain logistics to minimize cost. So these are the four pillars of analytics. Next is data processing, batch versus real time. So what is batch processing? Batch processing involves the processing of data in large volume or batches typically collected over period of time. Data is collected, stored and processed offline in batches, usually at scheduled intervals. Characteristics of batch processing are high volume offline processing, scheduled execution. Advantages are scalability, cost effectiveness, and robustness. Use cases of batch processing is commonly for tasks such as data warehouse, ETL operations, report generation, and batch analytics. Real-time processing is also known as streaming processing or event-driven processing. Involves the continuous processing of data as it is generated or ingested into the system. Data is processed immediately upon arrival, enabling real-time analysis and response. Characteristics of real-time processing is low latency, continuous processing, and it is event-driven. Advantage is timeliness, operational efficiency, and dynamic adaptation. Use cases of real-time processing is applications such as fraud detection, real-time monitoring and alerts, IoT analytics, algorithmic trading, and recommendation systems. So next is future of big data and BI. So future of big data and BI are mostly four pillars: data governance, AI, data automation, and data-driven culture. Data governance is nothing but as organization increasing relying on big data for decision making, ensuring data quality, integrity, and security becomes paramount. Data governance frameworks will continue to evolve to establish policies, process, and controls for managing data assets effectively. Artificial intelligence will become increasingly integrated into BI and big data analytics solution, enhancing their capabilities for big data processing, analytics, and decision support. Data automation will streamline and accelerate various aspects of data management and analytics, from data ingestion and pre-processing to analysis the reporting. Next is data-driven culture. Cultivating a data-driven culture will be essential for organizations to harness the full potential of big data and BI. This involves fostering a mindset where data is viewed as a strategic asset and decisions are based on empirical evidence rather than intuition or gut feeling. So next is OpenLM and big data ready for tomorrow. OpenLM upcoming generation is going to launch soon, which is primed for the future with the tech stack optimized for big data, leveraging Apache Spark Kafka for real-time processing and a seamless integration with BI tools. OpenLM ensures high-speed analytics and actionable insights. Its scalable architecture and robust data governance make it a strategic asset for enterprise navigating the complexities of the digital age. So that was all for the webinar. Let's move to the Q&A. Let's jump to the questions. If you have any question, please write down in the chat box. So we have a question like how the four pillars of the analytics can help in business. Let me share my screen again. Here, in the four pillars, yeah, hope my screen is visible. So the first pillar represents that what happened in the past. By analyzing what happened in the past, uh, we can go to the next pillar, which explains that why did it happen. Historical data is very informative as a business grows, that why a product sales get increased or decreased. The historical data helps us to diagnostic it, and predictive analysis help us that what is going to happen in future likely, so that we can be ready for the future. And the next pillar, prescriptive analysis, is actually prescribing us to how to do better in business. So these four pillars does help us in our business. So there's another question. Do OpenLM working on streaming big data? If yes, what is the technology stack they are using in achieve that? Yeah, our new generation is likely going to our new generation is going to launch soon, which kept mind about big data, and all the technologies and tech stack we are using is keeping that on mind. And of course, we are working with the streaming data using Apache Spark and Kafka for it, and for the data processing purpose, and all the things, the data report will be managed by the BI tools for real-time reporting. Is there any other question? So by following this QR, you can subscribe to our newsletter to keep updated, and also you can write us in info@openlm.com. So these are the upcoming webinars. Feel free to join. Thank you for joining this webinar. So